welcome to this demo about auto-scaling workloads in Kubernetes. My name is Sara Pulido. I'm a technical evangelist at Datadog and also certified Kubernetes administrator. And this is my Twitter handler and my mail address in case you want to reach out afterwards. Just so you know, Datadog is a monitoring and analytics platform that helps companies improve observability of their infrastructure and applications, including, of course, Kubernetes as a platform, but also the applications that you run on top, the workloads that you run on top. And this is what we are going to be talking about today, the workloads and workloads scaling. So why do we need to scale a workload? So when we scale up, usually it's to cope with demand. We have several, suddenly we have new requests per second. We want to cope with that demand. But we also want to go back and scale down, basically to save cloud resources, to save money. Why we would like to do that automatically with auto-scaling technologies? Basically to be able to react faster to changes. So suddenly there is a spike and you don't have to wake up in the middle of the night in order to scale your infrastructure. So there are two ways in which we can scale our workloads in Kubernetes, vertical and horizontal. And vertical basically means increasing the size of our pods. And we are going to explain a little bit later what that means. And horizontally, which basically means increasing the number of replicas that we have for a particular pod. So we are going to be using this workload for our demo. This is our application. It's a sample application, e-commerce application, and most of the logic happens on the store front end. This is a huge monolithic application that has been split up into a couple of services, but most of the logic is still happening here. Let's start by vertical pod scaling in Kubernetes. So when we define our pods and the containers that are running in our pods, we usually have to describe the resources request for that pod. And we use millicores for CPU and millibytes for memory. And when we do that, we make that definition of resources requests and limits. For the request, we establish a contract with the scheduler. And basically means that the scheduler is to make sure, it's going to make sure that the node that your pod is going to be scheduled on has the capacity for those requests, and those are going to be just for you. So what happens if we request less than we need? So for example, we requested 500 millicore and actually we're using 700 millicore most of the time. So when the scheduler needs a space for some other pods, probably your pod is going to be rescheduled because it's using more than it actually requested in the first place. But what about if we do the opposite? What about if we use more than we need? So we request 500 millicore and actually we only need 70 millicore. That means that a lot of cloud resources are going to be underutilized because, again, this is a contract with the scheduler and therefore there are going to be those resources for you even if you don't use them. So the question here is, how much should I request then? And a good way to answer that question is by monitoring your system. If you have your applications all well monitored in a monitoring system, then you can find things like the number of memory and number of CPU. To put an example, for example, here we are using the kubedns pod deployment, and we can see for every container that we have, the amount of CPU that we're using over time, the amount of memory that we are using over time. So by monitoring that, we are able to know exactly. But there are also automated ways to do that. And the Vertical Pod Autoscaler tries to solve that. The VPA, or Vertical Pod Autoscaler, is a component in Kubernetes that basically makes recommendations for resources based on usage data. So for example, if you have requested 500 millicore and 500 millibytes, the VPA is going to start gathering data and it's going to tell you things like, actually, you should be fine with 200 millicore and 50 millibytes because that's what your pod is actually using. And the Vertical Pod Autoscaler can work in three different ways. In recommendation mode, so no changes. On changes when it reschedules, the scheduler reschedules your pod for other reasons, or automated in which it actually reschedules your pod. So let's see the first one, the recommendation mode. We have this front-end service, and it's requesting 100 millicore and 100 millibytes. Let's see if that is enough. Remember that our application is a monolith application, probably needs a need more. So we are going to deploy the VPA, and once we have deployed this controller and the CRDs that are related, then we can create an object called Vertical Pod Autoscaler with the target of our deployment front end and the update policy off. So we are going to create that object, and after a while that I've speeded up here in this demo, you get the results, and you can see that CPU actually we need less, but actually we need a lot more memory. So probably time to change our pod definition. What about horizontal scaling? So again, horizontal scaling, as we said, is the number of replicas that we have for a pod, and increasing or decreasing that number of replicas. We can do that manually using the declarative way in Kubernetes, telling the Kubernetes API what we want in result. For example, let's say I want 3 replicas. I already have 2. So the controller is going to check that there are already 2 replicas, and it's going to tell the scheduler to schedule a 3rd one. So the famous reconciliation loop in Kubernetes. But wouldn't it be great to do this based on data? And that is exactly what the Horizontal Pod Autoscaler tries to solve. I can do things like how many replicas do I need based on resource usage, and I can create an object, for example, that says as soon as my pod goes above 50% of the CPU that I requested originally, please scale the deployment. But that doesn't look like the best metric to drive our scaling events. When we want to track our applications, we use something like the RED framework or the workload signals or any other framework out there. The RED framework says that the most important metrics are requests per second or per millisecond in your application, errors, the number of errors that your users are getting, and latency or the time of the amount of time that it takes for your service to do some work. This seems to be metrics that are a lot more useful for our users, that users care about. And this is exactly what the HPA with external metric server or custom metrics tries to solve. How many replicas of a pod do I need? Based basically on any metric value. And the external metric server is a specification that any metric provider can implement. And Datadog actually implements it through an agent called the Datadog cluster agent. So it gathers the metric from any metric that we have in Datadog and then expose that metric as external metric server that the HPA controller can understand and can drive those scaling events thanks to that. With that, we can do a lot of things that are a lot more useful, like drive my events, my scaling events based on latency, like in this case. And this is the example that we are going to see. In this case, we don't need to scale. So we have the latency of our service in 7-something seconds. We are going to check how many metrics do we have, and if we have anyone that it's interesting for this particular problem. So we have this 99p, which is the P99 latency for our service. This is the one that we are going to be using thanks to custom metrics and external metric server. So the first thing that we are going to do is to create an object that basically says, okay, with a minimum of 1 replica, maximum of 3, targeting the deployment front end, track this metric, the P99 latency, and drive those events if it goes above 7 seconds. So once we apply this definition, we create the object, then we can see that the cluster agent in Datadog is actually going to get that metric. And we can see what value is already getting by basically asking the Datadog agent the status of the cluster agent. And we can see that it's already above our limits. It's already 10 seconds. So probably we have started to see some scaling events, but let's also add more fake traffic to even scale it more. So after a while, we will see all these pods being created. And we can see that in this case, it went up to 3 replicas automatically, but the latency went down to 3 seconds, which basically was the goal. And if we describe the HPA object itself, you can see all those scaling events that happen because the metric went above the level that we want it to be. But again, this was a little bit too radical. We only have 1 value for a metric. It was 7 seconds. As soon as it goes above 7 seconds, we will start those scaling events. And as soon as it goes below 7 seconds again, it will stop those scaling events, or even will go down the scaling events. So it seems like if you're using a metric that changes a lot of values all the time, you're going to have many scaling events that you didn't expect, and those scaling events are not for free, basically, because you need CPU to do that. For that, Datadog has created this open source project called Watermark Pod Autoscaler, which is completely open source that we want to contribute back to Kubernetes, that tries to solve exactly this. So basically, extends the HPA. So instead of just having one value, it has two values, a high watermark and a low watermark. And in between those two, there are not going to be any scaling events. It also has some other nice features like scaling velocity of the number of replicas that I want to scale at a time. Also cooldown periods, or the number of seconds that I want to wait in between scaling events. Let's see our final demo with this one. So we have here our resource definition, and we are going to basically do the same thing as the VPA. We are going to deploy the controller, the WPA controller in this case. Once we do that, we have that controller up and running, and we can create a WPA object, or Watermark Pod Autoscaler object. We are telling 1 to 5 replicas with a high watermark of 11, a low watermark of 4. So let's start doing things like applying that object. Once we apply that object, we can see that the object has been created. We don't have a value yet. It may take a couple of seconds to get that value. So after a while, we are going to get the value back from Datadog. And it's going to say, okay, the latency right now is 10.5, so it's below our target. So let's apply some fake traffic. Once we apply that fake traffic afterwards, what we are going to be seeing is those scaling events. Right now we only have one replica, but once we apply that traffic, probably it's going to go up. So let's do that. We have applied that traffic, we wait a little bit, and after some time we are going to start seeing those replicas being created because the latency went up. Okay, some takeaways from these demos. VPA can help you maximize your host utilization without getting a lot of rescheduled pods. Also, HPA can automatically horizontally scale your pods based on resource or object data, but a lot more interesting is to use external metric server like Datadog to drive those scaling events based on any metric. And finally, the WPA, or Watermark Pod Autoscaler, which is an open source project by Datadog, extends the HPA to allow for more fine-tuning your scaling events. If you want to see this in action and you want to talk to any of the representatives, please visit our booth. We will be able to help there. Thank you very much.